Hi everyone. My name is Stanislav. I work as a data scientist in eBay. And today, we'll be talking about why the models that show good performance on offline tests suddenly can fail on the production during the production. So I will not be covering today clever fine-tuning tricks or how to select the most suitable model architecture or loss function. Today I will be covering something that is oftenly missed when we're trying to investigate why models have a good bad performance. So we were talking about how the data collected and how this process can influence the actual production quality of the model. So the model was fine, the dataset was lying. So by this statement, I want to emphasize that not any problem with our quality of the model quality lies on the model architecture or training processes. Something was in our case something was bad during the dataset collection. So by saying dataset lying, I don't saying that the target was written incorrectly, or we did something wrong with the storing the data. But I was just saying that dataset was lying because it wasn't representing the actual production distribution correctly. So our case is language learning app. So it was a mobile app for everyday practicing, language practicing. So our business target was to create a model which will predict the churners, so the users who are likely to stop using the app soon. So this is the classic problem we faced many times. So we thought about we will not have any issues with that when we're training the model. So the goal of the model was to predict the churners, and then using these predictions, the app will just push the users, send them notifications about provide them some offers, special offers, or just notify them to return them to the app. So when we achieved first metrics, flying metrics, it was okay, the model performed okay. So we received the 80% precision on the test set, approximately 75% on the with the recall, and everything seemed fine. However, production disagreed with that. So when we actually deployed it, the model, we saw that the model performance dramatically dropped on the production. So recall was dropped by approximately 40%, and we noticed that the segment of users, the first week churners, was especially missed by the model. So the model systematically missed these early new learners, new users. We also tried to play with the threshold of a model, decrease it to increase the volume, but it didn't help. So it increased the volume, but like it hasn't solved the main problem that these new learners were missed. So of course, first aspects were like the model itself. Like, what will be if we change the model architecture? Try, instead of the light GBM model, we can try the more complex models. Maybe the signal is too complex, or like, yeah, as I've told, we can play with the threshold, but it also didn't help. Or we can tune our hyperparameters of a model, but nothing of this helped us. So we try to focus on the other thing. So especially specifically on the training collection. So we understood that maybe something is wrong, not with the model, but with something that we like how we collected our data set we trained the model on. So we plotted like what are the distribution of all learners, which model sees during the production, during the actual inference. So this is the real population of the model facing during the deployment. So after that, our analytics table was collecting users. However, not all of the users, but only the users which produced enough events. So they completed the onboarding, passed few lessons, and generated enough events to appear in the analytics table. And what we did with the first attempt, we used the analytics table to train the model on. So that meant that we missed the target group of the users new users that churns early. So if we see on the distribution, so the amount of amount of users that have 0 events is highly underrepresented in our training data set, is almost 0, and with the this is the main problem we saw during the this phase. The offline dataset overrepresented the habitual learners, which have more events, more stable communication with the interaction with our app. However, on the other hand, the first week learners, the new users, were highly underrepresented in our training dataset. So these confused the learners who, for example, were confused by onboarding or just haven't used the app much. They just were nearly invisible for a model during the training. And in production, on the other hand, new learners continuously appeared, and many of them left after not generating enough events to end up in our analytics table. So this is the group, actually, this is the group of early churners that our product wanted to help to return to the app by pushing the notifications and giving some special offers. However, the model haven't seen this. And yeah, the model didn't fail to generalize the data. We just never show it this population. Yeah. So after we fix it, we like add some events for early for new users to appear in the analytics table. We retrain the model with this data, with new population, and yeah. We saw after retraining or redeployment, we saw that the scores of the model during the production also increased. However, like a few weeks later, we noticed the quality of the model dropped again. So we was forced to investigate what was going on this time. And during the investigation, found that like the product team launched a new feature, this track feature into the app. So, and this track feature influenced the behavior of users significantly. So, what track features does? It's like the forces for a user to regularly open the app and like make some interaction with it. For example, in our case, it was to complete at least one lesson. So that means that users, after the strike feature was deployed, they changed their usual behavior. So they started to, like, if we imagine, some of the users start to hunt for this strike. And like they started to open the app just to maintain their streak. After fixing the problem with the training data set, we added some logs and retrained the model, which showed better production results. Yeah, however, it wasn't for so long because the product team launched a new feature, the strike. And yeah, as I was telling, the strike feature forced the users, so for some of them, not for all, to change their behavior. Just they started to open the app more regularly. However, so the number of sessions per user increased. However, the average length of the user sessions became shorter. So the interaction with the app for this new pattern of hunting for strike, the interaction became more shallow. So they just opened the app, completed one lesson, and then we're done for the app for today. So this strike reward completely changed the behavior of some users. So the patterns, the model trained on the previous data was outdated. The pattern it learned were not working anymore. So yeah, this is like some example of how some of the features, the main features on the model rely on changed. So yeah, approximately it was two times more sessions per learner per day, and the average session length became shorter. So we also added the new data. So understood that we cannot use the model for long and not to retrain it. So we need to continuously and regularly retrain the model. So we set up the scheduled retraining of the model, and with the new version, we compared how the performance was for the existing learners and for new learners who was streak heavy users, and we found that the quality of the model on the existing learners haven't changed so much. However, for this new pattern, strike-heavy users, like the performance increased significantly. So yeah, for a fix for this stage, we have need to like continuously fed to the model new data, fresh data. Also, we implemented the checks for score drift. So we like when we fine-tuned when we trained the new version of a model with the new data, we need to we're checking if the distribution of prediction, the probabilities, how it changed. So if it changed significantly, then we need to like investigate why it was then. So to be more accurate with our deployment. And also, not only the probabilities of the model prediction we need to monitor, but the features itself. So as we've seen before, like the strike feature directly affected the main like features like average session length or the average number of sessions per day per user. So by checking how the data distribution of the features behavior through time, we can just spot if some important changes were affected the users. It can be not only the app forced like changes like this strike feature, but it also can be external changes like in the world. So yeah, this case had like two main biases of the data set, but there are a lot of others. So we're just lucky not to have them during that case, but also in the other projects I had like several times that we have prepared the training pipeline with the pre-processing of our raw features. So some bad joins, historical bug fields, and missing the value default. And the serving pipeline, on the other hand, did the same job, but at some stage, one of them can usually the serving pipeline can evolve and change, and some values can change. For example, the default value can change, or even how the data is encoded. For example, previously the training and serving pipeline operated the country, encoded the country in the same way. So for United States, they put it encoded into US code. Yeah. However, with the product evolution, the serving pipeline started to encode it differently. So for United States, it started to save it encoded as United States. However, the training pipeline still was using the old encode. So the model didn't use to this data distribution, so it fails again in production. It also usually can be very helpful to look at not the average metrics, average loss, but look at the more specific on the specific cohorts. For example, in this use case, it would be very useful to understand the loss for the returning learners and for the new learners apart. So by doing that, we can see these this difference in the model performance for these two segments. But it can be like not only like new learners or old learners. It can be like for different countries, for different ages. Like you understand for your own segment what is most useful for you. So yeah, with the hidden bias taxonomy, it can be split into 4 sections. So the selection bias asks who disappears before training. The temporal bias asks which state of the world of the app have we show the model. The pipeline bias shows asks where to train, and the serving disagree. And the aggregation bias shows which segment fails under the average. So yeah, before training, we need to inspect the dataset like production. So we need to compare the populations. So we have the source, we have the data which passed the eligibility requirements, and as a last step, we have the data that we collected in the training. So we need to pay attention to all the steps to not lose any essential data. We also might find it useful to analyze the data with respect to some useful cohorts, and preserve the data distribution for these segments the same as they were in the production. When we would like to transfer this into our training data the same, because if the segment can experience app differently, it can experience the data set itself differently. So it also is valuable to challenge your test features, train features availability at the prediction time. So it is easy to compute a feature using offline, using the historical data, using all the data possible during the offline. However, during the prediction, we might not have enough data to compute the feature with the same accuracy. Some of the features can be absent during the online inference. So thinking about this can help us to eliminate some leakages. Yeah. When we're with our case, we used the Evently tool to measure the data drift, to analyze it, and to compare the model's version. So it is quite easy to do with this app, this tool, and Grafana for dashboards and alerts for production monitoring. However, for the manual review, we did the population accounting, the segment checks manually, but this is not the one tools. There's a plenty of them. So so before training, it can be useful to ask these questions before training the model on. Who is missing? What can change during the time? And like what do averages hide, like what segments can be can be processed by a model poorly, and yeah, where can production and trained data disagree. So after the incident, we built a dataset that produced the closer to the actual production state population data. We also prepared a continuous retraining process, which was automatic, and like if there was a large row loss, or yeah, it triggered investigation. Also, yeah, when we implement new features, we analyzed it in terms of freshness and feature statistics. We try to analyze the model evaluation with respect to the main cohorts, and during the during the deployment of the new version of model, we use the shadow deployment to compare the results, compare the distribution probability, yeah, to make the process of changing the model more like fluent. So this is all for my topic for today. Yeah. So if you have any questions, I would be happy to answer. Thank you for your attention.
All right, thanks.
So which model did you use for training?
Yeah, it was LedGBM boosting.
Okay.
Yeah.
Hi, thank you for your talk. So you mentioned the aim was actually to find these turn candidates and then ping them so that you engage them, right?
Yeah, yeah. Mm-hmm.
Did you monitor how this influenced their behavior afterwards?
Yeah, of course, but yeah.
And how would that like influence your continuous training? Because you mentioned you have been retraining.
Yeah, yeah. Actually, it is a good question, because yeah, actually the data, the business decisions that were like based on the model predictions actually influenced the user behavior also. So yeah, there was possibility that model was like retrained on their signal, but yeah, we done we didn't do anything specific with this at this time, but I know that it can happen. But like for us, it was we're lucky to avoid this situation. Thank you.
All right, do we have any more questions?
It's a bit of a joke than a question, but like, who did you hate more? The people who changed the data input, or the people who shipped something very different, not consulting with you? And how do you maybe approach this like stakeholder management and keep in the right context that is relevant for your work?
Yeah, I think it was like a failure of the management not to not to notify us about this decision. So yeah, but they came to us and say why it doesn't work.
All right, if there are no more questions, then thank you very much.
Thank you.